Welcome to Methodical Math. The goal of this video is to solve a simple probability problem. It's going to be a short video. I'm just going to handle one exercise. First, let's look at the problem. And the way of solving it is to divide the desired outcomes by the possible outcomes. So let's first start off with all the possible outcomes. Each one of the 4 passengers can independently choose to leave at one of the 6 floors. Therefore, there are 4 passengers assigned to 6 floors. So there are 6 to the power of 4 possible outcomes, since each passenger has 6 choices. Each passenger has 6 choices. This is how we write it down. And now let's move on to the desired outcomes. We need to count the number of ways in which no more than 1 person leaves each floor. So, it has to be precisely 1. This means that each floor can either have 0 or 1 passenger leaving, but not more. Since now we're looking at the desired outcomes, let's get into that. We choose 4 different floors out of 6. Choosing is represented by this symbol. The symbol is known as a binomial coefficient and is representing this formula. You use it generally whenever you have to choose something out of something else in probability. And now for each choice of floors, there are 4 factorial ways to assign each person to a different floor. What I mean by that, what the factorial means essentially is this sort of thing. So multiplication of each numbers, starting from 1, incrementing by 1 all the way to 4 in our case, to the number in the factorial, or decrementing, however you want to look at it. In our case, this means that for every time a person leaves the elevator, there's one less person in the elevator, meaning one less person choosing the floor. So that's why we are using a factorial over here. And let me spare you the calculations and just go straight to the solution of our desired outcomes. The binomial coefficient is going to be equal to 15, and the factorial is going to be equal to 24. If you want me to cover each one of these things in detail, just write it down in the comments. So the solution to this problem is 360. There are 360 ways of which this event can happen. So now that we have desired outcomes and all possible outcomes, as I said in the beginning of the exercise, we just simply need to divide the desired outcomes by all possible outcomes to get the probability. Of course, this means the solution to this is 1,296. So the probability is going to be roughly 28%. Now let's tackle something else. What if we want to see the probability that all people leave on the same floor? To do that, we just need to consider that there are 6 floors. We need to choose a floor and then assign the passengers to that floor. So there are 6 choices for each floor. And now we need to assign the passengers to said floor. Once a floor is chosen, all 4 passengers must exit on that chosen floor. And since the passenger independently chooses a floor, we assume each floor has the same likelihood of being chosen. The probability that a passenger will choose one floor is going to be 1 over 6 to the power of 4. Why that? Because this is probability of one floor being chosen over the others, and 4, the power of 4, represents the passengers, just like last time. The power here, or let me just give you a general rule of thumb, the power in the probabilities means that the same event is happening multiple times, let's say 4 times in this case, and independently. If they were dependent on each other, let's say one person was leaving on a different floor, we will be using factorial, meaning this n exclamation mark over here. but since we aren't, we are going to be using the power. This is a general rule of thumb. So, given that there are 6 floors that can each be the floor where all choose to leave, the probability P of A, yeah, I forgot to write that on the previous exercise, but this is generally the solution. This is going to be the probability P of A, as given here. Is going to be equal 6 multiplied by 1 over 6 to the power 4. And that is going to be equal to 6 times 1 over 1296. You can notice that this denominators come on both in the first exercise and the second exercise. And that is going to be 6 over 1296, which is 1 over 216, which is something very small, whatever. Thank you for watching. If you have any questions, if I didn't explain something clearly, feel free to ask me in the comments. I also teach people mathematics. I offer private tutoring, so if you struggle with anything in particular and would like me to personally help you with something more complex than simple exercises we tackle on the channel, also feel free to write in the comments. I have tutored multiple people before, and I have helped to pass multiple people. Thank you for watching.